Okay, so we have had three lectures until now, and all we have done is in the first lecture we learned how to do the basic mathematical operations on MATLAB, and in lectures 2 and 3 we learned how to use vectors and arrays and matrices on MATLAB and how MATLAB is going to deal with different problems in terms of arrays. So from today's lecture, we are going to go into the code area of MATLAB, where we are actually going to write longer codes. And there are two kinds of codes, scripts and functions, and we're going to go over the basics of both today. Uh, but do remember to stop me around 3-4 minutes before the class, because I also want to go over some hints for the homework, the second homework that's due on Thursday. So you have two homeworks due on Thursday, correct? This Thursday? Yeah. So also the lab classes, they are starting from this week. So the first set of lab classes will be today. Feel free to ask the TA about your, if you have any doubts on the homework. Okay, so let's start today with the lecture. So as I said, we typically write two kinds of codes on MATLAB. The first type is called script file. So we are going to do some script files today. So what is a script file? A script file is a .m file. So whenever, for example, remember that one code that we wrote in the first class to draw out a circle? That was a .m file, and that was a script file as well. So we already know a little bit about what a script file should be like. But let's do a few more examples. So if we just focus on the highlighted parts over here, a script file is executed by typing the name of the file. We know that already when we coded that file to draw out a circle. You can also run it directly from this Run tab on your MATLAB window. You guys can see my screen, right? The MATLAB screen, yeah. Okay, so let's go back to the code that we wrote in the first lecture, which should be here. So okay, so this is the code that we wrote in the first class. So this is a typical example of a script file where you have certain input parameters and you are trying to calculate something, but instead of running the calculations on the command window where you have to type every single time you have to redo the calculation, the script file gives a nice way to set up a file that can repeat the calculation whenever you want. So if you guys don't remember this file, just go back to the lecture one. But essentially what we did is this: we are trying to draw a circle for a certain radius r. This line over here is giving MATLAB the information on what that radius is going to be. Then to draw the circle, we had to figure out the coordinates of all different points along the circumference, and to figure out the points, we need to know the angular location of that point as well. So this is how I set up an array of angles, and we use those angles to figure out the coordinates of each point on the circumference using trigonometry. So r cosine of that angle is going to give you the x coordinate, and r sine of that angle is going to give you the y coordinate of that arbitrary point on the circumference, and then we plot it. So as we know by now, we can run it like this by simply using the Run tab. And if I press some value for the circle, it's going to show up as a different sub window in a moment. So anyways, you know what I mean. I have issues with moving from one screen to another because typically the MATLAB sub window for the graph is going to show up on the different screen. Okay, let me bring it over here. Yeah, so it's going to show up in a different window. Anyways, so this is a typical example of a script file, but we are going to, and you guys already have done a similar problem, I think, in one of the homeworks. But we are going to do some more script file examples today. But the bottom line is, this is something that would help you to repeat a calculation again and again. So right now, if we had actually written down all these things on the command window, you have to type it out again to like figure out a circle for a different radius, which you don't have to if you have a script file. Okay, so let's now look at this example. And please open your MATLAB and you can type after me. On that note, I heard some student feedback that they still don't have MATLAB on their machines, which is kind of unfortunate because in lecture 1, I think I went over how to install MATLAB. So just if there is still someone who doesn't have MATLAB on the machine, go to the D2L main site, not the lab sites, go to the D2L main site, go to the content, and go to the MATLAB logistics. And there you will see this particular file, MATLAB installation updated. It's a PowerPoint, so just follow those the instructions on the slides, which are basically screenshots from my computer when I was trying to install MATLAB. And if you have questions, just let me know. You need to have a working MATLAB on your computers by now. Okay, so assuming you guys all have MATLAB, let's try to write a code for this particular example. So the question is, okay, so this is a system of 3 equations where x1, x2, x3, they're unknown. So for example, the first equation from here is 5x1 plus 2rx2 plus rx3 is equal to 2. The second equation is 3x1 plus 6x2 plus 2r minus 1x3 is equal to 3. And the third equation is 2x1 plus r minus 1 multiplied by x2 plus 3rx3 is 5. So this is just a stylized or an array version of writing a system of simultaneous equations. And here we have 3 equations, and x1, x2, x3 are the 3 unknowns. Someone might argue that r is also unknown here, so we need to know some value for r to figure out to solve this system of equations, because otherwise if r is also unknown, you'd be having 4 unknowns, r and then x1, x2, x3, and you cannot solve 4 unknowns from 3 equations. So if someone asks you to solve this system of equations, you need to know r, and we are going to see that as well as we write the code. So you have a clear idea of what the equations are like. So this is the right hand side of the equation. These are the cofactors on the left hand side. These 3 different rows. Now we may think of this, since we are in the world of MATLAB, we have to think in a way what MATLAB is going to do in order to solve this equation. So what MATLAB is going to do is to think in terms of arrays, as I've been telling you. And that's why I have formatted this problem in the form of arrays. Now, if you think of this big array as this matrix A, the unknown variables as this column vector X, and the right-hand side values as this column vector B, then we have a nice way of thinking in terms of arrays in a way MATLAB is going to approach this problem. And we are going to use that same inner thinking of MATLAB to write the algorithm for the code. So let's start that. So we are basically trying to write a script file that's going to solve this system of equations. So to write a script file, as I told you in the first lecture, the very first step is clear all, which clears all the variables from MATLAB's memory. Close all, which would close any graphical subwindows that might be open. And CLC, which is going to clean up, if the command window has some stuff already in there, it's going to clean up the command window. So let's write those things. Then this problem is for solving a set of simultaneous equations. Equations with 3 unknowns. So someone tell me what should be the first step in terms of I don't want the exact syntax. I want how you guys are thinking about the algorithm. What should be the first information that I should supply MATLAB?
Would we set up the matrix A as the 5, the 2R, the R, the 3, the
Okay,
6, the 2R minus
that's a good
1.
suggestion. So we definitely MATLAB definitely needs to know what that matrix is. So let's plug in that. So A is, now we are going to use the tools that we learned in the last two lectures, as in how to introduce matrices to MATLAB. So now we are going to assume that we are all experts in those operations. So we are going to introduce this particular matrix to MATLAB. So the first row is 5 2 multiplied R. Remember that we cannot just write 2R or 2R like this, because to denote multiplication on MATLAB, you always need to have this star sign. So this is the first row. The second row is 3, 6, and then 2 multiplied by R minus 1. And then the third row is 2, R minus 1, then
Well,
3.
don't you have to tell MATLAB what R is?
You are very correct. We do have to tell MATLAB what R is. So I was going by the suggestion of the first student, because we also need to figure out where the possible errors might be. MATLAB does need to know what R is, and we are going to come to that. But let's finish writing this line. And this is a very valid point, because otherwise, whenever MATLAB comes to this particular line, this seventh line, and it tries to set up this matrix A, it doesn't really know what R is. So yes, indeed, we do need to have a value for R. So let's now do that. And we have to do it before MATLAB encounters A. So let's do that here. Input, what is R, question mark, and this /n would take the control on the command window to the next line. So /n and single quote close. So yeah, so we introduce R here and then A. The next thing, what should be the next thing to do? Anyone? So MATLAB now knows what is this matrix. And so what is
Can
the
we
next
put in
one?
the B matrix?
The B matrix, right? So we are still trying to solve this x1, x2, x3. So we don't need to tell MATLAB anything about it yet, but we do need to tell MATLAB what the right-hand side values are. So B is a column vector, right? So after I plug in this first element 2, should it be 2 space 3, or should it be 2 semicolon 3? Should I
Semicolon.
semicolon? You're right, because here we are thinking about a column vector. So the first row just has one element, which is 2, and we go to the next row, which has just one element, which is 3, and we go to the third row, which has 5. Very good. So we have the A matrix, the B matrix. Let's now think about how to solve for those x1, x2 numbers, x1, x2, and x3. So in usual terms, if you think about a single line algebraic equation where ax is b, of course, you solve for x by dividing b by a. But now we are dealing with matrices, and matrix division is not that easy. So the way we are going to do it is this way. Conceptually, it's still going to be sem, which is b divided by a, but the way it's done here is inverse of a multiplied b. So basically, we are bringing a to the right-hand side, and since a is a matrix, that mathematical operation of bringing a under b as a denominator is equivalent to writing this inverse of a multiplied b. So you need to remember this particular mathematical operation, because it's slightly different than how you might tend to think, but this is how the matrix division operation is going to be like. Okay, so
So can we not transpose B to do it? Would that be a different answer?
We can try it out and see if we get the same answer or not. So you are suggesting that what if this is A transpose multiplied B? Is that what you suggested?
Yeah, would that work? I was thinking like B times or B
Okay,
transpose times A, but that might be the same. I don't know.
yeah, B transpose times A. Okay, so let's try all those things out and see if which one works. But I know that this one would work, and you can find it out very easily by solving it by hand with a simple number for R. So you can cross-check your answer based on all the different outputs that we might get by following different techniques. But let's first do it one in this way and then try out the other ones. So inverse of A, B, and let's leave it at this. So let's now save this. So save as, so this is lecture 4, code 1. Fall 2020, lecture 4, code 1. Okay, so let's run this now. So it asks for a value of R. Let's just type out R as 1, and we get this output. So later on, when you review this lecture note, just type in 1 for R and see if you get the same number. In the sense that just do out a hand calculation. But let's try out the other suggestions that we received. So let's do B transpose multiplied A. Is that what the suggestion was?
Yeah, it was.
Okay, so let's save this. So let's remember what we have here, minus 0.0312 for X. And let's run this now. Again, press 1 to be R. And we don't get the same number. And this definitely is wrong. It should not match out if you have, yeah. So make sure that whatever number you might get fits with your initial calculation for initial problem setup. For example, here we are ending up getting a row vector for X. Of course, X is not a row vector, it's a column vector as per the setup. So this one would not work, but I know of at least one more way of doing this. So this is called a matrix left division, which is A and a reverse of the division sign and B. And if we save this, I know it still gives the same, no, the correct answers, which is again X is equal to minus 0.312, which is what we had received, we had obtained in the first way of solving this, which was inverse A multiplying B. I prefer this one because it seems more logical to me, because you are trying to divide B by A. Now, basically, you can think of it as A inverse to the power of minus 1B. So A to the power of minus 1 is different than A transpose. Remember that. So basically, we are doing this operation, and to do this operation, the corresponding MATLAB syntax is inverse of A. Okay. Anyways, any question on this one? So do
Yeah. In the input, what does that the backwards or the forward slash do?
Okay. That's a good question. So let's see what that one does. So let's remove that backward slash and n and see what happens. By the way, since it's already open, I need to finish this and then come here and then save this and then run. So what happens is when we remove that backward slash and n, this prompt, this control prompt, it stays on this line. So it's something very trivial. And if you press in the number for R, that one would be typed in the question.
I'm just like kind of confused.
On the other hand, if you have
if it's in main,
this in the
you don't
syntax,
need to have
and if you say
like a parameter like the void. So
and
I
then you
just
run
I'm so
it,
confused on how it works.
the control goes to the next line, which is just nice. So in terms of writing a cleaner and more user-friendly code, you typically tend to have this backward slash n at the end of the question under the input prompt. Okay. So, any other question for this one? Okay, so if you go to the lecture note, yeah, so I have tried to go through all the different steps and the possible errors that might show up. For example, in this example, instead of having R as an question that MATLAB is going to ask you, I have already plugged in a value of R, which is not always the most useful thing to do. But the moral of the story is whenever MATLAB encounters this line where A is being input, which has R in its elements, it needs to know what R is. And you need to make sure that R is there in MATLAB's memory when MATLAB encounters those lines of the code. And this thing is going to show up in many codes as well, and you are going to do this kind of errors because that's the process of learning. Like you will write an equation where you have already not covered all the input variables in that equation, and MATLAB is going to give you an error. So this is a possible source through which error might creep into your code. So remember this particular aspect. Now, what else? Okay, so I have most of the screenshots here. Just try to follow them. One more thing in this particular example. Okay, so over here is along with figuring out what is x, which is x1, x2, x3, I've also tried to figure out what is the determinant of that big matrix A. So if I ask you in the test, like what is the determinant of A, what you do is add another line here. So determinant of A is dit, which is the MATLAB syntax to evaluate the determinant, and this. So let's save this and see what we get. And if we run it again, okay, first I need to close this and then run it again. So now if I type 1 for R, you get two outputs, those x values, x1, x2, x3, along with the determinant when MATLAB has plugged in R as 1 into this matrix and just calculated the determinant for this matrix. Now, for those of you who don't remember exactly what determinant is, I think I have this slide over here. So this is, all of you guys have done it at some point. This is how you calculate the determinant, and you can double check your MATLAB's work by using these formulations. Okay, any questions on this one? So on the homework or on the test, when I ask you to write a script file, you should be writing a script file and not a function file that we are going to cover next. And otherwise, the overall way you think about the algorithm in a script file or a function file is very similar. But we are going to see how they're different. They're slightly different, and we are going to cover that next. Okay, a few things to know before we wrap up this segment on the script file. Never name a script file by the name of the variable that it's trying to compute, because as you go through your engineering careers, you will be writing longer codes, and the names of the variables are not going to be as simple as XYZ or ABC. It can be much more complicated. It can be temperature in engine 1 or temperature engine 2. So remember that don't name your script file with the same name as a variable which is inside that code. So avoid that. The name should always begin with a letter, and unless you clear out the variables from MATLAB's memory, they are always going to be there in the workspace. Just like if you look at my screen on the top right under the workspace, or if you look at your own MATLAB screen, if you have successfully run the codes, the calculations that we are doing or the variables that we are computing, those numbers are being stored. So you have to remove them to make sure that you can use them again for some other calculation. Okay. So that wraps up what I wanted to cover on script files. Let's go to what is a function file. So a function file is also an M file. It's also saved under your MATLAB directory as a .m file. Now, a function is more like some of you might know other programming languages like C, Fortran. So there you come across things like subroutines. So a function file is more like a subroutine, which you can use again and again, and you can call a function file into a different code. So if you already have created a function file and have saved it under the MATLAB directory, you can actually call it through a different code. So that function file sort of acts like a tool that you can use from here on. So that's the beauty of function files, which you cannot do with script files. You cannot call a script file from a different code, but you can call those function files that you have saved under the MATLAB directory from a different code. That aspect of function files is probably not going to be that useful in this class, where we are trying to develop a basic conceptual knowledge on how MATLAB works. But if you end up using MATLAB in your engineering work later on in the other courses and later on in your careers as engineers, you're going to use this aspect of function files. So that's why I have this line over here. So once you get to know MATLAB well, this is where you are likely to spend most of the time, writing and refining function files, and sometimes files. That's not the problem. It might not need any function file, and you can just manage it with a script file. In fact, if you ask me in my research, most of the times I end up just writing script files because I don't use MATLAB that much. But based on how much you use MATLAB, this is where you are going to spend most of your time, on function files, on script files. So make sure that you understand the overall concept of how they work. Okay, so with function files, we input some parameters. The function file has all the secrets, all the calculations, all the mathematics in it, and then it would give us some output data. So a couple of things before we go into an actual example, why people use function files. It's just easier to debug. So debug is when you write a big code and there is an error which is very difficult for you to figure out. But if you're using function files to build up different parts of that code, you can look at the function files separately, and it might be easier sometimes to figure out where that bug is. And it's just a more systematic way of writing a programmed code. Okay, now let's look at some specific examples. There are two subtypes of function files. The first one is called anonymous function, and we are going to see this one first, and then we are going to go into another broader category, which is the one which is more often used in actual engineering work. But let's look at what is anonymous function, and you need to know how to use this as well, because most of the times on the test, if I remember correctly, I tend to give 2-point questions for these anonymous functions, because you don't really have to write a big code for this, as anonymous functions are meant for command line computation. So you don't write a .m file for this. You just set up a function on the command window. So let's see how it's done. And because things are done on the command window, I cannot really make a 10-pointer question from anonymous function. So I tend to have like 2-point questions. Okay, so let's look at some examples now. So here in this example, we are trying to set up a function fx, which is going to evaluate 2x sine x. So let's see how we do that. And this is examples on anonymous functions, which are meant for command line computations. Okay, so let's think about this particular function now. Let's call it f1. Let's call it function 1, lecture 4. And this is the syntax over here. So function name is what is function 1 lect4 in this example on my command window, then equal @input list. So if you think about this particular example, what is the input? The input is only x, right? Because this right hand side is dependent on just x. So the input is just x, and then we write out the actual function. So 2 multiplied x multiplied sine x. So let's press enter now. So you should see this on your command window. This implies that a function handle, that's what MATLAB likes to call this kind of anonymous functions. A function handle has been created where the information on the function is in that function handle and it's dependent on X. So now let's try to figure out a value for this f for a certain value of X. So let's see how we do that. So if we write, so let's call it A, the value that we are going to calculate is function1 leg 4. So basically we are trying to calculate f1. So what would be the value of this function if X is 1? So if I press enter, I get an error because I mistyped it, I think. Yeah, I missed a T over there. So it's function1 lect for 1, and the answer is 1.6829. So if you guys have your calculators handy in front of you, just let's double check what MATLAB did. And while double checking it, remember that under sine or cosine, the argument in the trigo operations in MATLAB, they're always in radians. So if your calculator is set in degrees, you need to change it back to radians. So mine, I think, is already in radians. So it's 2 times 1 times sine of 1. So it's 1.6829. So it came out correct. Let me try one more thing. I think it might still work with these brackets because sometimes it might be a longer function than just 2x sine x. So it still works if you use brackets as well. So if I press 1, you still end up getting the same number. So this syntax over here can also include brackets.
I think your mic went out.
Can you guys hear me now?
Yeah, gotcha now.
Okay, yeah. Yeah, something is very wrong with my computer. It just goes away sometimes. So if this happens, just shout at me. You guys can hear me, right? Okay. So now we are going to set up an anonymous function to calculate the hypotenuse. So we are going to follow the same syntax. Function name is equal at input list and then the mathematical expression. So for that, the function name is up to you. So hypotenuse is, suppose the function name, equals at the rate. So tell me what should be the inputs here? Someone?
A and B.
A and B are the inputs because you are trying to calculate the hypotenuse, which is C. So A and B are the inputs. And then the mathematical expression is square root of A square plus B square. So this is the function handle, the hypotenuse. Now suppose we are trying to calculate C. So let's type C equals to hypotenuse. And now we have to give the input parameter values. Let's assume that A is 3 and B is 4. So C should be square root of 3 square plus 4 square, which is 5. And here you go. So you can set up this kind of function handles to figure out numbers that can be calculated by saying simple 1-line, 2-line command window calculations. Okay, so I have this example here, and I have taken the screenshot from my earlier work as well. So that covers the first subclass of functions, which is anonymous function. Let's look at the more dominant category of functions, which is user-defined functions. So with user-defined functions, as we saw in anonymous function, it can just handle one output, right? But with user-defined functions, it can handle multiple input values and it can give out multiple outputs. And because of this reason, in engineering or science, we mostly end up using user-defined functions. So let's go directly to some examples. But before that, let me show you, this is the overall syntax of how you would start a function, a user-defined function. So this is the first line that should be there. Function, output variables, function name, input variables. So it's a syntax that you are going to follow. The function name is going to be determined by you, but this function comes in along with the MATLAB syntax. The output variables are the variables that you are trying to calculate out of that code, and input variables are the variables that would go into the calculation inside the code. Now there's a very handy tool. You don't always need to remember this syntax because MATLAB has a very useful tool that you can directly use. So look at my screen carefully now. So if I go to the top left, and if I just go to the drop-down menu under new, and I type function. So if you do that on your MATLAB, you'll see that a new editor window is going to show up, and it's going to contain this same syntax. So you don't really type it, you don't really need to type it out. You can directly get it from this new, and then just press function, and you get this. So it is really handy. Otherwise, there can be some syntax related errors when you write a function. But now we have this overall structure that we can directly use. So again, as I said, the function comes from MATLAB's own inner structure, but we have to figure out a name for this particular code. Now, I think I can go over this at some point. Yes. So whenever you set things up, of course, these output arguments are the name of the output variables from whatever calculation you're carrying out. Now this untitled should be the name of the code that you are going to save. So suppose if I type it as fall 2020 code 2, right? So this is the name that you are going to. So when you save this, you'll see that this is the name that's going to show up over there. But we'll come to that later on when we are ready to save this. Now, in terms of an actual example, let's go back to the same example that we did with the script file, but let's try to think of it now as how to solve it using the user-defined function structure. So again, tell me what should be the output arguments here if we are trying to solve this. Anyone?
The X values?
The X values, right? So would it be X1, X2, X3, or would it be just X? So, should it be just X or X1, X2, X3? Oh, I can see, but you guys can, like, I don't always follow the chat window, but someone says just X. So that's right, but just speak out, that's fine.
No, my mic's not working.
Oh, there were many questions on the chat window. This is fun. I never checked the chat window. Sorry, guys. As I think I did tell you in the first lecture, I don't always keep track of the chat window. That's my bad. But if yeah, just feel free to ask me the questions out loud.
Hello.
Anyway, so yeah, so it's X, just X, because that's MATLAB is thinking in terms of arrays. So that array is just X.
Oh.
What are the inputs here?
Hello.
Is someone saying hello?
I'm trying to fix my mic. It wasn't working.
Oh, okay, I see. Can everyone hear me? Okay. So what is the input here for this problem?
Is it R and then the A matrix and the B matrix?
It is R. The A matrix and the B matrix. The B matrix is just a set of numbers, so that's not really an input. That's going to go into the calculations in the meaty part of the code. But since A is dependent on R, you don't need to really set it up A separately. It's just going to depend on R. As long as you tell MATLAB what R is, you are fine. So just R as per this particular example. So let's now just copy a few lines from here because it's just quicker. So now we are coming to this part of the code where you actually include all the calculations. So let's come over here. So let's delete these parts and let's type out what it's actually supposed to be meant for. So remember a few differences compared to script files. The function starts with this particular very specific syntax, and it always ends with an end. So don't miss out on that end. If you are using this trick, end would be there. So whenever you are trying to copy something from something else, make sure that you don't delete this end. Okay. Okay. So I think we have most of the things in place. Let's save this for now. So let's save as. And now see, this is something new. So if you have already set up the function name as fall 2020 code 2, that also shows up automatically by default when you save it under the MATLAB directory. This is just MATLAB's extra functionality to double check to make sure that you don't make an error over here, because this name and this name here, they should match. So I saved this. Okay, so let's try to run this. So since I already have this input question, what is R? If I type 1, I get the same numbers that we were getting. By the way, it also gives a second output for X, because that's supposedly is the output. So it automatically gives that output along with this X. So if we can suppress this quite easily by doing this. So let's just remove determinant from here. We don't need the determinant, at least on this problem. And if we suppress this output, which is done by writing this semicolon, and if we save this again, and if we run it again, and if I again press R is equal to 1, we just get that output. We don't get that X twice. But that's not the more important part. Let's see what else we can do here. So suppose we don't need this line R. So suppose we delete that line, or better still, let's just comment it out for now. So this line for R is not there. And if I save this, I press run, we definitely get an error because we don't have R in the code. What else can we do? So there is another way to do this, to solve this problem without really inputting R in this line. So the way we do this is this. So solution, some variable name is this new function that you have created, fall 2020 code 2, and then plug in the value of R that you want in that function. So R is 1, and then you get the solution as this. So please try to appreciate how beautiful this is, because now this means that this function is always at your disposal to use whenever you want to carry out this calculation. You just need to tell it what that input argument is. And as long as you know the input argument, you don't really need to run anything. You can even just close this particular code, and suppose we are trying to figure out what is the output x1, x2, x3 for R is 10, when R is 10. So I just type this and we get the output. So as long as MATLAB can access this function file from the directory, it can always carry out this calculation. So this is the beauty of a function file, where you don't really need to always tell it what the value of R is. You just need to tell it when you are actually using that function or that calculation, and you can call this into any other code as well, and just make sure that it has the input to calculate the output. Okay? Any question on this one? Okay, so if you go to the lecture notes, I have tried to include every possible screenshot from my work. If you haven't followed what we discussed, just try to follow them from the lecture. One more thing that I wanted to introduce today would be how to deal with Excel files, but let's put this into the next class because I don't want to rush through this.
Didn't you wanted us to remind you to
Show you some hints for the homework.
yeah.
Yeah, so let's do that, but let me just cover this quick thing. So these are some syntaxes that I already have over here, and you can just copy paste them into your MATLAB. So this is how you read an Excel file. So for example, this particular example is a screenshot from my MATLAB. It shows you how you read an Excel file. So you'll find this test1 data file on your D2L. So if you go to D2L, if you go to Excel data for MATLAB, I've already saved this file. So what you should do is like download this file and save this under your MATLAB directory. And once that test1 data file is in your MATLAB directory, then you can just follow this syntax to figure out how you read Excel spreadsheets into MATLAB. So try to do that at home and let me know in the next class if you have any questions. And over here, I have more examples of simple anonymous functions. I have more examples of user-defined functions. And I have a full example where I show how to use the spreadsheets from Excel. So try them out at home and let me know if you have any questions. And here are some not so important things about how you display your outputs. So try to read them up. If you have any questions in the next class, just let me know. But more importantly, go through all these examples. The worked out examples, the screenshots are here. For example, for these ones, you can just copy and paste them on your MATLAB. Okay, so the homework from the class today is this. It's again going to be due next week, Thursday. And I think there's a question on the chat window. Is the homework due this Thursday or next? So the homeworks that are due this Thursday are the ones that were set last week. So the homework that was set after the Tuesday class and after the Thursday class would be due next Thursday. So whatever homeworks are being assigned from each week would be due on the Thursday of the following week. So that's the generic rule that we are going to follow. Okay, so yeah, so let's go to the hints for homework 2.
It shows homework 2 and 3 are due September 10th. So were those the ones that were assigned last week?
These are the ones that were assigned last week.
Okay, so
today
but those are
so for example, today is homework 4 that's getting assigned. So in the last week, we had assigned homework 2 and homework 3. And you will find them at the end of the PDF lecture notes. So those are due this Thursday.
okay. I just wanted to clarify because it says the due date on D2L is September 10th for those specific assignments.
September, yeah, it should be September 3rd. So I probably did it wrong. Yeah, let me correct that after the class. So it should be September 3. Anyway, so okay, so let's take a quick look at some hints for some of the homework problems. And this is also a screenshot from my work. So I think the question was for this homework, this is homework 2. We had a big G matrix, how to enter the G without really entering all these elements row-wise. So this is how you do it. Just focus on the non-zero subparts of the matrices. So you first cover this part, which is 2, 6, 3, 9, and you set it up as a small matrix A. Then you focus on this part 1, 2, 3, 4, set it up as a small matrix B. And then look at the third part and set it up as a small matrix C. Once you have this, then think about the entire G matrix. So in G matrix, from first row to first column, from first row to second row, and from first column to second column, is A. So type that out. And we have done the similar examples, smaller examples, but similar examples in lecture. Now this part is J's third to fourth row and third to fourth column. So set that up, third to fourth row and third to fourth column as B matrix. And these two are J's fifth to sixth row and fifth to sixth column. So this part would be assigned as this matrix that you have already started. So once you set these 3 lines up and then just type G and press enter, you should get that complete big G matrix. Okay, so this is another hint for the problem 5, where I think most of you would be able to do this. It's just removing some parts out of a matrix, and we have done this plenty of times in the lecture using this structure of a null matrix. Any questions on this? If you have more questions, just shoot me an email, and you can ask the TA as well. And to remind you guys, the lab classes all start from this week, and the TA is going to send you a Zoom link before your corresponding lab class. And the homeworks are due this Thursday, so I'll need to go ahead and correct that.
I think on the homework, like I think it was number 4 on the third homework, when it kicks out a really big matrix, do we have to take a picture of that whole thing or just like the entry?
Try to take the picture of the whole thing. Just try to make sure, try to think that what the TA might need to grade it successfully. So try to get as many screenshots as you can. But if the TA has, I'm not going to grade the homeworks unless there is something specific to something. So the TA is going to be in charge of the grading. So if you have any questions on the graded homeworks, make sure that you ask him in the class. Okay, any other questions? Okay, thank you guys. So I'll see you on Thursday, and try to make use of the lab classes to get your homeworks done. Okay, bye.